Another way to make a carbon-carbon bond formation reaction occur is through a Diels-Alder reaction. Now, when you do this, you need to have a diene and a dienophile. The dienophile can be an alkene or it can be an alkyne. And the diene, I'm going to draw some groups here in red and green, and some in blue too. I'm going to draw the inside groups as red balls, and the outside groups here as green balls. Okay. When you do this, we've talked about this in class, but the two red groups, or the groups on the inside of the ring, always rotate up together or rotate down together. And the green ones would always rotate up together or down together so that you get the right stereochemistry. That's very important, that you make sure that you do a disrotatory ring closure. And we talked about this as being, be a gangster, be a cowboy, but don't be a wangster. We don't want to do a conrotatory ring closure. We didn't tell you why. I told you it had to do with the Woodward-Hoffman rules, but we weren't going to go into too much molecular orbital theory to understand why. The important part is that you get the stereochemistry right. Okay? So when this mechanism works, the alkene or the dienophile or the alkyne, which could also be the dienophile, acts as an electron pair donor to make a carbon-carbon bond. The double bond here then would make a double bond at this location. This pair of electrons moves over here. It's a 6-electron rearrangement that is done with heat. That would be the factor. The mechanism is very easy to draw. The stereochemistry is not as easy to draw. But you are always going to end up with a 6-membered ring with a double bond. So it's always going to be a cyclohexene. If you used an alkyne, you would have a 1,4-cyclohexadiene as a result of it. And those groups I wanted to make sure I drew on there for you so you could see the stereochemistry. Okay, so the blue ones are where they were a moment ago. The green ones could either have rotated up together or down together, and the red ones also could have rotated up together or down together. So this is one version. You also could have made its enantiomer, and I'll draw that one over here. I should have given myself more room. The ones are where they are. Again, the red ones could have rotated up together, and the green ones could have rotated down together. But they will always go together, is the point when you're doing these types of reactions.